Have you ever wondered why construction projects with highly sophisticated 3D visual models still suffer from massive budget overruns, delayed handovers, and chaotic asset management? The truth is, the industry has been looking at the wrong problem. Welcome to Module 1, Foundations of BIM and Information Management, where we begin our masterclass in information management and the international standard ISO 19650. In this opening session, titled What is BIM? From 3D models to information and value, we are going to completely redefine the way you look at built assets. This masterclass is designed to shift your perspective away from basic drafting tools and look directly at data architecture. Over the next few minutes, we will look at how moving past raw geometric modeling allows you to unlock true business value for owners, facility managers, and contractors alike. Let's move into our primary problem statement to examine why traditional approaches to technology frequently fail. Let's look at a classic project mistake. An executive team buys expensive software licenses, sends their engineering modelers to training, and assumes their project handover issues are solved. This is the software trap. When project teams focus exclusively on 3D geometry, the resulting asset record is an empty shell. It looks like a pristine digital building, but it contains no deeper operational intelligence. This creates severe real-world consequences at the end of the project lifecycle. Facilities management teams inherit unsearchable data silos, leaving them completely unable to locate basic equipment warranties, manufacturing data, or critical compliance records. Imagine trying to maintain a complex hospital facility when you cannot even verify the fire ratings or installation dates of the hardware assets. To prevent this structural breakdown, we need to completely redefine our educational milestones. Let's evaluate the learning objectives for this lesson. To ensure our approach is accurate, let's establish our core learning objectives for this session. First, our primary goal is to define building information modeling, or BIM, strictly in information management terms, rather than as a localized software tool. Second, we will learn to systematically separate the visible 3D model geometry from the underlying metadata it actually carries. Third, we will analyze the severe financial cost of poorly managed information and contrast it with the measurable value of structured information. Fourth, we will demystify the multidimensional terminology from 3D all the way to 6D, explaining them as functional uses of information rather than progressive levels you must climb. Finally, we will position the rest of this entire course as a comprehensive study of the management of information, not modeling. Let's address the industry's biggest misconception first. Before we can build a world-class framework, there is a massive industry misconception that we must clear up first. Let's state it explicitly. BIM is not a specific software application. It is not Revit, it is not Navisworks, and it is not automated clash detection. In reality, BIM is the systematic management of information across the entire life of a built asset. This technical discipline relies on a balanced triad: people, structured data, and process checkpoints. The management discipline itself remains perfectly constant, while the individual software tools are completely interchangeable. If your delivery process lacks structured data and clear checkpoints, changing software will not improve your outcomes. Let's look at how the international standard defines this concept. To achieve international alignment, we must ground our work in the precise definition provided by ISO 19650. The standard defines BIM as the use of a shared digital representation of a built asset to facilitate design, construction, and operation processes, forming a reliable basis for decisions. Let's break down the three structural pillars hidden within this definition. First, the phrase shared digital representation means that many distinct project parties must actively rely on it as a single source of truth. Second, the standard refers to structured information, not just drawings, which ensures our data can be automatically read and processed by computer systems. Third, the phrase forming a reliable basis for decisions explains the entire point of the discipline. We do not create information just to look at it. We build it to drive accurate business decisions. Let's break down the acronym itself to see how this shifts our day-to-day workflow. To break free from outdated software habits, let's reread the 3 letters of BIM from the inside out, starting with the final letter. The absolute core of the acronym is I, which stands for information. Information is our foundational noun, and it represents the actual asset of value. Every piece of geometry, software tool, and team workflow serves this data. Moving backwards, M stands for modeling. Modeling is simply one of the ways we structure information so it can be queried, parsed, and searched. It is a means to an end, never the end itself. Finally, B stands for building. This represents the physical operating asset that an owner must run safely, efficiently, and sustainably for decades. By rereading these letters, you ensure your modeling always serves long-term operations. To see how this looks in practice, let's examine our structural iceberg model. Think of a project's digital delivery like an iceberg floating in the ocean. Above the waterline, you find what most people see, the 3D geometry. This answers basic spatial questions, such as where is the object and what shape is it? However, the real substance of the asset sits entirely below the waterline. This hidden mass contains your engineering specifications, asset attributes, structured data, documentation, and detailed project schedules and costs. It also contains the operations and maintenance data required by facilities teams. Take a fire door as an example. Above the waterline, it is represented as a simple rectangle in a 3D model. Below the waterline, it holds its fire rating, manufacturer warranty details, and scheduled maintenance regime. Without that metadata, the model is useless to an operator. Let's define the precise data vocabulary we use to manage this data. To master information management, we must keep 3 words completely distinct: data, information, and the model container. Let's track how data evolves through 3 distinct steps. Step 1 is raw data. These are raw, context-free values. For example, seeing the string IP65, the date December 3rd, or the number 450 tells you nothing on its own. Step 2 occurs when we transform that data into information. This means the data is placed into a clear context so it can be acted upon. Now those raw strings become Pump P-04 is IP65 rated and was serviced on March 12th. Step 3 is the model container. This is the structured file, such as a federated model, a drawing, or a database schedule that holds both the 3D geometry and the information together in a single package. Let's address how these containers are used across different dimensions. Let's demystify a major marketing concept: the dimensions myth. In many industry circles, 3D, 4D, and 5D are treated like consecutive levels of an evolutionary ladder that you have to climb. This is incorrect. Dimensions are simply marketing shorthand for specific uses of information attached to an asset object, like a steel beam. Image illustrating BIM dimensions, connecting an asset object to geometry, delivery date, rate, and maintenance regime. Let's trace these branches. Geometry represents spatial coordination. When you attach a delivery date to that object, you enable construction sequencing, which is called 4D. If you attach a unit rate or cost factor, you enable financial estimating, known as 5D. When you map a maintenance regime, you support operations, or 6D. ISO 1965. O completely avoids generic dimensional labels, focusing instead on defining explicit information requirements and purposes to prevent waste. Let's look at the financial damage caused by ignoring these requirements. Why does information management matter so much to a project's bottom line? This chart illustrates a painful reality. The cost of an information error grows by an order of magnitude at each stage of the asset lifecycle it survives. Let's track an information discrepancy across time. If an error is caught early during the design phase, it takes mere minutes to fix with zero material impact. However, if that same error survives a siloed handover and reaches the construction site, it results in days of delay, material waste, and expensive physical rework. The worst-case scenario occurs when the error survives all the way into long-term operation. Catching an information defect here can trigger an expensive operational shutdown or a major safety incident. Let's look at how structured data management reverses this risk curve. True business value comes from three core pillars: process efficiency, decision quality, and whole-life asset value. Let's directly compare a traditional project environment with an ISO 19650 structured environment. Without managed information, project teams constantly argue over document versions via messy email chains. With ISO 19650, you establish one trusted source of data, where every container has a clearly defined status. In a traditional handover, the client receives boxes of unstructured PDFs. Under the standard, handover delivers a fully structured asset information model. This means that instead of an owner spending months resurveying their own building to figure out what they own, they can query the digital asset record on day one. Finally, critical risk and safety knowledge is carried forward rather than being lost at project closeout. Let's look at how this impacts the complete life cycle. Built assets do not exist in a vacuum. They progress through a continuous loop known as the asset life cycle. This life cycle flows through 6 continuous stages: strategy and brief, design, construction, handover, operation and use, and finally, renewal or end of life. Image showing the circular stages of the asset life cycle from strategy to end of life. You must understand that decisions made early in this cycle echo across the entire life of the asset. Because of this, ISO 19650 explicitly plans from operation backwards. We start by defining exactly what the facility manager needs to run the building during the operation and use stage. Once those needs are clear, we work backwards to determine what must be delivered at handover, built during construction, and drafted during design. Let's review the myths we need to eliminate to make this process work. To establish a world-class delivery framework, let's review the common industry myths we need to drop immediately. First, look at the myth that BIM is simply the 3D model. The ISO 19650 reality proves the model is merely one information container. The true business value sits within the managed information beneath it. Second, teams often assume that more detail is always better. In reality, over-modeling wastes massive amounts of engineering effort. Your target should always be to deliver just enough information to fulfill the specific purpose. Third, many believe that BIM is solely the modeler's job. The standard clarifies that information management is everyone's job, including owners, lead designers, and contractors. Fourth, dropping the idea that we'll sort data at the end is vital, as information must be planned from the start. Finally, remember that software is never the standard. ISO 19650 specifies strict business processes, never a commercial product. Let's define what this means for our course structure. So, let's summarize what this course is actually about. This training program is not about learning how to click buttons in a specific software application. Instead, it is about mastering the international discipline of managing information to a rigorous international standard. The ISO 19650 discipline focuses on 6 core information capabilities: how we ask for information, how we plan for its delivery, how we check its validity, how we exchange it securely, how we secure it against threats, and how we use it to decide on critical project milestones. This professional discipline turns expensive, chaotic software setups into genuine, measurable business value across any complex project lifecycle. Let's look at the 3 pillars that allow us to operationalize this process. How do we actually operationalize this process on a live project? Think of this framework as your project's technical operating manual. Information is able to travel across different software tools because of specific structural agreements made early in the timeline. This trusted project information architecture rests on three pillars. Pillar number one is the information standard. This enforces consistent object naming, asset classification, engineering units, and format structures across every single team. Pillar number two represents methods and procedures. This defines predictable paths for data production, quality checking, formal approval, and final information exchange. Pillar number three is reference information. This provides shared technical resources, baseline data packages, and standardized templates. Let's look at how this changes our view of information valuation. This slide covers the core mental shift of this masterclass. You must treat information as an asset in its own right. On any modern project, the physical asset and the information asset are digital twins. This means you must formally commission, verify, accept, and maintain both assets with equal discipline. A complete, trustworthy asset record significantly lowers long-term operating costs and directly supports facility safety. If a project team delivers a physical building but fails to deliver the corresponding asset information model, they have delivered only half of what the client paid for. To see this reality in action, let's walk through a real-world engineering example. Let's analyze a worked example comparing two different project teams tasked with delivering the exact same highway asset. Team A adopts a traditional software approach. They build a visually impressive 3D model, run automated class checks, and hand over raw model files at project completion. Team B, however, adopts a disciplined information approach. Before they draw a single line, they ask the road authority exactly what operational data they need to maintain the highway over time. They look directly at asset variables, such as the drainage invert levels, the sign inspection regimes, and the specific pavement layer specifications. Let's look at the contrasting handover outcomes for these two teams. When look at the handover reality, both teams can technically claim they did BIM using the exact same software. However, they achieve completely opposite outcomes. Let's look at the Team A outcome. Because they focused entirely on geometry, the road authority receives unusable files. Their operations team has to spend months extracting asset data by hand and completely loses historical safety context. Now, let's look at the Team B outcome. Because their data was structured from day one, the authority imports a clean asset record directly into their maintenance systems. Planned safety inspections and operations begin smoothly on day one without any manual data entry. Let's review the core question that ensures you always achieve the Team B outcome. As you advance through the rest of this masterclass, you will encounter a lot of technical terms, acronyms, and standards. To cut through the technical noise, I want you to apply one core question to every single acronym you see. What information decision does this help me make? If you can answer this clearly, you truly understand the underlying information management concept. If you cannot answer it, you have merely learned a label, not a concept. Always focus on how data drives human decisions. Let's synthesize everything we've learned today into our 5 key takeaways. We have reached the end of our foundational session. Let's review our 5 key takeaways. First, BIM is information management across the entire life cycle, not just 3D modeling software. Second, the visible model is merely the tip of the iceberg. The real business value sits in the data beneath it. Third, you must keep data, information, and the model container structurally separate in your workflows. Fourth, poor information management exponentially increases the long-term cost of project rework and operational risk. Finally, ISO 19650 plans from operation backwards to create whole life value for the asset. Let's lock in these concepts with a final check your understanding session. Let's validate your understanding of these core principles with 3 quick questions. Question 1. in ISO 1965. Oh, what are 4D and 5D? The answer is that they are specific uses of information attached to objects for a purpose. The rationale is that they are not arbitrary levels to climb, but clear information requirements. Question 2. When is an information error cheapest to fix? The answer is early, during the design phase. The rationale is that the cost of an error grows tenfold for every stage of the project it survives. Question 3. A fire door's greatest long-term value lies in its what? The answer is its information. The rationale is that fire ratings, compliance identifiers, and warranties matter infinitely more to operations than precise 3D geometry. This completes our opening lesson. I will see you in the next session.